This is Tyler Ellsworth and Alex Morford, and this is the second project for ME416, the design of a feed water system to cool the MSU High Performance Computing Center. The MSU Office of Infrastructure Planning and Facilities has determined that the MSU High Performance Computing Center will need 1 megawatt of cooling. They have determined that there are 1 million gallons of potable water per day that can be used in the feed water system, and that the water can increase 3 degrees Fahrenheit from its inlet temperature of 57 degrees Fahrenheit. The system should be a shell and tube heat exchanger with a relatively compact design, and the pressure drop in the shell and tube heat exchanger should be minimized. This system will need to be easy to service for cleaning and disinfection.
It is determined from the specific heat of water, the mass flow rate of water, and the allowable temperature change that 1 megawatt of cooling is not possible for this heat exchanger. The system created maximized the amount of cooling that could occur within the parameters. Stainless steel and copper were the only materials considered because they will be appropriate for contact with food due to corrosion resistance, and both are long-lasting and don't require much maintenance. The heat exchanger length will be fully utilized. Removable bundles and channels further simplify the serviceability of this heat exchanger. Propylene glycol was selected as the hot stream fluid because it may come in contact with water, and if so, would not be detrimental to the health of people who come in contact with it through the water supply. The pressure drop will be kept below 1/10 of a bar in both streams, which is 10% of the atmospheric pressure and determined to be a low pressure drop. The final design provided 1/3 of a megawatt of cooling for the MSU Computing Center. It is 304 stainless steel, which is cheaper than copper. There are 20 baffles at 14-inch spacing, and there is 22.7 feet of tube length required. The propylene glycol enters at 100 Fahrenheit and exits at 90 Fahrenheit. The price is approximately $86,000 with minimal maintenance required and a lifespan of several decades.
AspenTech Corporation in Redford, Michigan is the first choice for a supplier of this system. They are located approximately 75 miles from campus and provide stainless steel heat exchangers. They have experience with the beverage and power industries. Fluid Chillers Incorporated in Lansing, Michigan is the second choice, and we recommend getting quotes from both companies.
Even though this system was maximized for cooling capacity, there is still 2/3 of a megawatt of cooling required for the computing center. The system is relatively expensive at $86,000 and takes up the entire space allowed. The MSU Office of Infrastructure Planning and Facilities needs to determine if this is appropriate for the cooling needs. If the computing center cuts the cooling requirement or more water leaves the reservoir, this system should be reevaluated. Some additional results are shown.
Any questions?